Let's start for response question number 1 by Jalen Littman. First, let's take a look at what they give you. A block of mass M1 travels horizontally with a constant speed VO on a plateau of height h until it comes to a cliff. The toboggan of mass M2 is positioned on level ground below the cliff as shown above. The center of the toboggan is a distance of d from the base of the cliff. So now we're going to try to solve the problem. Part A says determine D in terms of VO, H, and G so that the block lands in the center of the toboggan. The two equations that you need to know is that your initial velocity equals your distance divided by your time, and your height equals 1/2 your gravity times your time squared. So since they don't give you any numbers, you have to solve by variables, and you have to isolate one of the variables. So the first variable you're going to isolate is T. And to begin by isolating T, you're going to multiply 2 by both sides to get 2 times your height equals gravity times your time squared. Then you're going to divide both of those sides by your gravity to get that your time squared equals 2h divided by g. And then you square root both of those sides to get time equals the square root of 2 times your height divided by your gravity. Since you're trying to solve for d, you have to go back to the first equation. Your initial velocity equals your distance divided by your time. So you're going to substitute what you just found for t into that equation to get that your initial velocity equals distance divided by the square root of 2h divided by your g. Then you're going to multiply both of those sides by the square root of 2 times your height divided by your gravity to get the final answer of your distance equals your initial velocity divided by, times the square root of 2 times your height divided by your gravity. Part B. The block sticks to the toboggan, which is free to slide without friction. Determine the resulting velocity of the block in the toboggan. So since you're trying to find velocity, you can look at this as a conservation of momentum. So your initial momentum will equal your final momentum, and the equation for momentum is mass times velocity. So first you're going to do your mass 1 times your initial velocity equals your mass 1 plus your mass 2, since the 2 stuck together, times your final velocity. Again, since I don't give you any numbers, you're talking about variables, so you're just going to divide both sides by m1 plus m2 to get your final answer of your final velocity equals m1 times your initial velocity divided by m1 plus m2.